Okay, so on to number 12 and an explanation of how to do it. Notice that even I messed it up late at night, and that's what happens when you're tired. But this is a section that's all about elimination, and it's all about lines. So ultimately, you should try to be reaching something that looks like this, right? It should look like that. And obviously, these do not look like that. But let's focus on just one aspect of it. Expansion. And here's a little problem you have. I'm going to take these two here as an example because you can take them individually. What's going on here? It looks like it's 2 times something minus something, right? And it is in a way, but it's hard to see how that minus affects the bracket. Over here, it's on the next line, it's 4 times something minus 3 times something. And it's like, what happens once we expand it? Well, let's use the minus 3 because it's an actual number. And we'll just remember this is our goal, a line formula. And when you have a minus 3 that's clearly right beside the bracket, it's saying, yeah, this is going to end up a bunch of pluses and minuses, but for in the meantime, bedmass order says I have to solve the brackets first, which I can't because that's just a y, and then I have to solve through multiplication or division. And this minus 3 is distributing through the bracket, which means it multiplies each thing individually. So your next step is to identify each thing individually. And here's the mistake a lot of people make. They keep that minus separate. And they just look at this as 3 and y. But this minus belongs to that y, just as this minus belongs to that 3. Okay, so that means what's going on with this bracket is minus 3 times 3 times plus 3, because that's the first thing in that bracket, right? That first thing in that bracket is a plus 3. And the second thing is a minus y. And then we do minus 3, because that's the thing outside, times minus y. Now, what can happen as you do this is you start getting confused and thinking that's minus 3 minus y. But it's minus 3 times minus y. And that's because this minus 3 out here is essentially multiplying everything in that bracket, which means it has to multiply the first one and the second one. So let's just focus and make a bracket to tell us that we're multiplying. What's minus 3 times plus 3? It's obviously a minus times a plus, and when they're opposite signs, it always becomes a minus. Finally, let's do this separate. What's a minus 3 times minus 1y? It's a minus times a minus, and when you have the same symbols, they become a plus. So all we do is we get rid of those two minuses and we replace it with a plus. Notice now that I no longer have anything multiplying except the 3 times the y, but it's become minus 9 plus 3y. So you'll discover when there's two things in the bracket that are adding and subtracting, and you multiply them by a number, it still becomes two things. It still becomes two things, and I kind of deleted it. It still becomes two things adding together. So again, I'll say that again. When you have one thing multiplying two things in a bracket, and those two things in the bracket are adding and subtracting, the result will be something that's adding or subtracting. In this case, adding. It's minus 9 plus 3y. And that will happen no matter what we multiply. So you should get used to, you don't have any problem when everything's plus, and that's because everything that's plus is straightforward, right? 2 times 3 is obviously 6. Plus 2, because there's always an invisible 2 here, times plus 4, which is obviously plus 2 times plus 4 is obviously plus 8. So we have 6 plus 8, which is 14. Now I want you to add up the thing in this bracket. 4 plus 3 is 7, and 7 times 2 is 14. We get the same answer whether we distribute the bracket or add up the bracket first, but we can't add up these brackets solely because y is an unknown number. It's still a number, it's just an unknown number, so we treat it like a number. So it's obvious why distributing is easy. It becomes something plus something. But I want you to notice that we were adding something in the bracket, and when we're done, we're adding something after distribution. That's important to notice, so don't end up with 6 times 8. And also when you're multiplying them, 2 times 3, it's plus 2 It's plus 2 times plus 3. Use your little multiplication symbols to remind you that you're multiplying them so that you don't actually plus 2 plus 3 add them. Because it's plus 2 times plus 3, then it's plus 2 times plus 4, and that's plus 6, but we don't put a plus when it's invisible, plus 8. That's what the result is, something plus something. The problem is when you have a minus in front of it. So all these have minuses, and that's probably why she gave them to you, so that you would understand what a minus is. But essentially, here's another way to think of it. If there's a minus here, every symbol inside this bracket is going to change. So this is a plus y here. It's going to become a minus whatever. Could be minus 3, whatever, but it's going to become minus. And this is a plus 4, so it's going to become a minus 4. This is a plus 3, so it's going to become a minus. And this is a minus y, so it's going to become a plus. This is a plus b, so it's going to become a minus. This is a minus 3, so it's going to become a plus. Let's see if that theory comes true. Now, I prefer to use numbers at first instead of that first one. So let's see. Let's just take this separate. And now the goal is we're going to take minus 3 and we're going to multiply it one by each thing in the bracket. Minus 3 times a plus b, so we don't have to write plus. And then minus 3, which is the thing outside the bracket, times minus 3. So I've used a little dot here to remind myself that I'm multiplying these things right there and right there. What's minus 3 times plus b? It's minus 3b. What's minus 3 times minus 3? It's plus 9 because it's a minus times a minus. Now notice that this b now has a minus in front of it right there, and it originally had a plus. Notice this 9 has a plus in front of it, and it originally had a minus. So when there's a minus out front, multiplying everything in that bracket, that's how you remind yourself if you got it right, because everything in that bracket will change its signs. Let's do it full scale now. Oh, by the way, what about this one? When I just have a minus in front, what do I do? Well, you can look at it this way. This minus essentially will change everything in their sign. That's all it'll do. But if you want to think of it as a number, it's always a minus 1 multiplying these things in there. So what's minus 1 times, I'm going to use this symbol for times, and then minus 1 times plus 4. So minus 1 times plus y is always obviously minus y, and minus 1 times plus 4 is minus 4. Now we can get rid of the brackets. Now notice what happened. That was a plus y, now it's a minus y. That was a plus 4, now it's a minus 4. So this minus symbol with just a 1, all it did was change their signs and got rid of the bracket. And why is getting rid of the bracket important? Because it's hard to see what to do next if you keep putting the bracket there. And essentially, when we distribute, what we're doing is getting rid of the bracket. Okay, let's do step by step. So whenever you encounter a long one, remember this is our goal over here. Our goal is, because we're in line eliminations, we're in chapter 1.4, we need to somehow turn this into that. Well, clearly up here, there's a number on the right, there's a y and an x on the left. And generally, they always like to have the x positive, just so you know. Okay, well, let's start. Let's break this all down. Those are both positive. So when they're positive, I'm not going to write anything. And then it's positive 2, because I do have to write it. If I don't write anything here, it's very confusing about what's going on. Am I adding? Am I subtracting? So essentially, this 2 out front has a big old positive in front of it. When we write the first term, we don't write the positive, just kind of like we capitalize the first letter of the alphabet. But it's there. So if you want to get used to just always putting a positive, put a positive. And then it's positive 2 times the next term. And I can just positive 2 times minus 1. And that little multiplication symbol reminds me that I'm going to end up with a plus or a minus, but in the meantime, those things are multiplying each other. So let's resolve this first part. What's plus 2 times plus 3x? It's plus 6x. But we don't write it when it's the first term. There is a plus there, but we don't bother. And then what's plus 2 times minus 1? Well, it's a plus times a minus, so it changes into a minus. So when the two signs are opposite, they turn into a minus, and when the two signs are the same, they turn into a plus. That's all you have to remember. Same, plus. So this is what I end up for this. But you might say, well, how do I do the rest? Okay, well, let's just bring it all down. we've got the first part solved, right? How do I solve this part? Well, you treat it as an independent. It's minus 1 times y and minus 1 times 4. So what's minus 1 times y? And we already just did this. Minus 1 times, in brackets, plus 4. Because I want this plus to be associated with the 4. Well, as we solved above, minus y, 1 times y is minus y, and minus 1 times 4 is minus 4. We've essentially gotten rid of the brackets. We've resolved this. And notice all the symbols changed because of this minus in front of it. So that means I can replace the entire thing. So I'm going to bring it down. And I can replace everything I just did with that. And now notice that I have 4 things that happen to all be subtracting. And actually this one's adding. But there's 4 things, and 3 of them are subtracting. And you might say, how do I know they're subtracting? Because in the brackets there was something subtracting, and in the brackets there was something adding. So in the end, because it's 2 things and 2 things, you're going to end up with 4 things that are adding or subtracting. And here's where you shouldn't have stopped. Here's where you did stop. There's only one thing with an x in it. There's no other thing with an x in it. So there's nothing I can do with that. There's only one thing with a y in it, and there's no other thing with a y in it. So there's nothing I can do with that. But here I have a number, and a number, and another number. So those are called like terms. And notice that this whole thing does not look like that yet. But it looks like we're close. Okay. So how do I put those like numbers? Well, if you get confused, when anything is adding or subtracting, you're allowed to rearrange them any way you like. So I could even put the numbers beside each other if I want. And that's called the communicative property, and I have trouble pronouncing it. Means that you can rearrange anything so long as the things that are multiplying stay together, 6 times this x, you're fine. So I got 6x minus 1y, minus 2 minus 4. What's minus 2 minus 4? Well, when they're both minus, you can simply add the numbers and just put a minus in front of it. 2 plus 4 is 6, so it's minus 6. And I know they're going to be minus 6 because when you subtract a negative number minus another negative number, we get more negative. Okay, so that means I've got this so far. Am I close to the top right? Yes, I am. I'm very close. I just can see that I have a number over here and a number on the right side. So how do I get all the numbers to the right side like this? Well, I'm going to add 6 to both sides. So I get 6x minus 1y, essentially 1 times y, but we just put minus y. Minus 6 plus 6 on the left, and then the minus 7, we're going to add 6 to both sides. Now, it's obviously whenever I add something to a negative number, it just disappears. And what's minus 7 plus 6? It's 1. Now, I ask you, after we're done expanding, does it look like a line? Yep, I got a 6x minus 1y is equal to 1. That one's done. I'm going to do most of them just to show you. And I would recommend at any time stopping the video, trying it yourself, and then resuming the video. But remember that we can break this down into 2 separate multiplication actions. It's this 4 multiplying everything in a bracket, minus this 3 multiplying everything in a bracket, and everything's going to add up or subtract when I'm done because the brackets, there's 2 things adding or subtracting. Also note that there's 4 things, 2 things here and 2 things here, so I should end up with 4 things adding or subtracting before I find the like terms. It is also possible to distribute more than just 2 things. So if I had minus 2x plus 3, I still treat this the same way. The 4 is going to multiply the plus 1, 4. The plus 4 is going to multiply the minus 2x, minus 8x. And the plus 4 is going to multiply the 3 plus 12. Notice I ended up with 3 things, and I had 3 things up here. They just all increased by a multiple of 4. Essentially, each thing in this bracket got multiplied by the thing outside the bracket. That's another way to think about it if you like. So we can try that method if you like. So I clearly have the 4 outside the bracket, right? So it's going to multiply each thing in the bracket. So I'll put a 4 right over. And notice it's a plus 4 outside. So I'm just going to multiply 4. Now there's a plus here and a plus here. So that's going to become 4 plus 4. And then there's a 4 plus 4 times a minus. And it's minus 2. So that's going to become a minus 8x. So that's one way to do it. Now I can leave that plus 4 in front if we want, just as a reminder. Plus 4 minus 8x was the distribution of that. What about this one? Well, let's use the same method. Let's bring it down and just remind ourselves that this minus 3, and the minus must go with the 3, is multiplying each thing in this thing. So what's minus 3 times plus 3? It's minus 9. And what's minus 3 times minus y right here? Well, I have a minus times a minus. They're the same symbol. Same symbols become a plus. 3 times y becomes 3y. And we do it to get rid of all those minuses. Clearly, I have all my things together, and remember, the brackets are adding or subtracting, so I should have 4 things that add or subtract. And then that's correct. Now I just bring my number down. Does it look like my line at the top left? No, it doesn't. So I can rearrange it. Now, technically, the x should have a positive in front of it. Oh, notice that I forgot to write the y here. So I had a minus 3 times minus y, and so there's a y there. So I can put the plus 3y over here. And I can even put the minus 9 here. Or if you want, I can put the minus 9 here and the plus 4 here. Now, which number is bigger, the 9 or the 4? The 9 is, and the 9's negative. So when I add a positive to a negative number, the bigger number will dictate the sign. So plus 4 minus 9 is minus 5. Now, once you figure out the sign, you can even take the number and take 9 minus 4. It's going to be minus 5. Try that technique a few times and see if it works out, which means I can push this down, and this becomes simply plus 4 minus 9 simply becomes minus 5. Almost done. It kind of looks like the line up top. Minus 5 is equal to minus 12. But I want all numbers on the right side, so what I'm going to do is add 5 to both sides. That'll get rid of this minus 5. And minus 12 plus 5, which is the biggest negative number? Which is the bigger number? 12. Is it negative? Yeah, so it's going to stay negative. What's 12 minus 5? It's 7. Minus 7. So that's a way to do it. Another way to do it is the number line. So if you're at 12 here, if you're at minus 12, and you're adding 5, it goes to the right, and we go up in numbers. So it goes minus 11, minus 10, minus 9, minus 8, minus 7. So it goes 1, 2, 3, 4, 5 jumps. So does this look like this up top? It kind of does. I mean, technically, all the x's should be positive in a standard formula. So I could change all the signs of this. Let's change all the signs. And it's still correct. If you don't, that's an interesting thing. So I want you to look at Desmos. If I have minus 8x plus 3y is equal to 7, I want you to see if the line changes if I change all those signs. 8x plus 8x minus 3y equals minus 7. Look at that. It's the same line. And that's because nothing changed. I multiplied the left by minus 1. I multiplied the right by minus 1. And if you do the same thing to the left side of the equation as you do to the right side of the equation, nothing changes. It's true in chemistry and physics as well. Same with if I just if I add 5 to the right side and I add 5 to the left side, or right side and left side, nothing changes. I can keep adding or subtracting numbers. Minus 3 over here, minus 3 over here, nothing changes. And to see it better, you just make a copy on the next line, and you just get rid of minus 3 and see if the purple line will match the red line. It does. Let's get rid of the plus 5. It does. So you can see that as long as you do the same thing to the right side of an equation, even multiplying, nothing changes. Now, does this now look like that. Yes, it does. Whoops. Bring her back. So I've successfully expanded this. And by the way, you could put these exact line in Desmos, and it will be the same line as that. This up here is just the simplified version of that, but they're the exact same line, and they will appear the same line on Desmos. So if you want, you can just type all that into Desmos exactly as is, and it will look the same as typing this in. Okay, so now we're to a stage we understand. We have a line, and to see where they meet, we must either do substitution or elimination. But 1.4 is all about elimination. I can see that this one has a -3 in front of it, and this one has a -1. So I'm going to multiply the top by 3. So I'm going to keep my original lines over here. I'm going to get rid of this line because this was just an example. And I'm going to take this line here. I'm going to multiply each number by +3. 3 here, 3 here, 3 here. I get 18x minus 3y is equal to 3. So all I've done, believe it or not, is that's the same line. I've just altered it by multiplying everything by 3 so that I can do elimination. Now notice our lines match. The 3, I have a -3y and a -3y. So when the symbols match, I must subtract each item. And here's how you can do it individually, and I prefer this method. So you take the top line in a bracket, I see plus 18x. You put a minus sign, and then in brackets you put whatever's the next bottom line. It's plus 8x. Then you can resolve these symbols here. So I have opposite symbols, right? So it becomes a minus. So it becomes 18x minus 8x. It's clear it's 10x. This, if you use that bracket method, you won't mess up the plus minuses each time. Let's look at the next one and try the same method. Open brackets, top line. We're going to subtract. And then the bottom line is also -3y. Well, I can see that I have a minus by a minus, and that rule means that becomes a plus. So I get -3y plus 3y, which is why when I add them, they always disappear. And finally, I get 3 minus plus 7. So I can see I have a minus beside a plus, so that, to get rid of the bracket, becomes a minus. I can see the -7 is a bigger minus number, so I'm going to end up with a minus number. What's 7 minus 3? It's 4. So that's the number I end up with. So I end up with this. And you always want to make sure that you multiplied your 3 out correctly, because it's clear that this is a little bit wonky. But, and actually, I don't think I got it. I'm going to check my distribution again, because I don't think I got that first. I don't think I got it right. I don't think these lines meet there. So let's see, 18x. And this is the problem, is even I make mistakes on these, because they get pretty convoluted. Oh, you know what I bet? I bet you I forgot to change the symbol on everything. I bet you I forgot to change like -7 or something like that. Let's go and see if I still have it. Probably don't. Let's see. Should become plus 8x minus 3y plus 7. Oh, it was fine. Okay, so I'm just going to make sure that I have expanded it properly. Okay. So you get 6x minus 2, 6x minus 2, minus y minus 4. So that's -6, and when I add it to the other side, it becomes -1. So there's my problem right there. How did I know I had a problem? It's because I knew that I was probably supposed to come out with something even number. When they're making you practice, they're not going to make it hell on you. So right there, I forgot my -1 instead of 1. Now I can multiply the top line by 3. And again, I get 18x minus 3y equals -3. So all I did was multiply each thing by minus 3, and I'm going to just keep a copy of my two original lines over here and get rid of that middle line. And over here I'm going to get rid of that top line. So all I did was multiply the top line by 3. And you do the same process. It's actually good practice to mess up, especially if you can spot it. So I get 18x in a bracket minus a plus 8x on the bottom. And I got a plus minus, so it's going to be 18x minus 8x, so I get 10x. And again, the minus 3y plus minus 3y becomes, minus 3y minus minus 3y becomes minus 3y plus 3y, and it disappears. And here I get minus 3 minus plus 7. So it's clear it becomes minus 3 minus 7. There we go. There's my mistake, which is minus 10. Two negative numbers will become a bigger negative number. You can just put the negative and add them together. Add the two raw numbers. So this is what I get. Right? So clearly I get 10x is equal to 10. Oh, equal to minus 10. See how easy it's done? Divide both sides by 10. And I get that. Now, I would use the simplest line. I'm halfway there. I use the simplest line to figure out my y value. So I'm going to put the minus 1 wherever I see x, and this is called substitution. When you find out something's equal to something else, you can put a bracket around it. So there's my x, and replace it with the thing that you know it is equal to. What's plus 6 times minus 1? How do I get the y alone? I'm going to add 6 to both sides. It's clear on the left side that the 6's disappear, so I'm left with minus y. And minus 1, which is bigger, the plus 6. What's 6 minus 1? 5. Plus 5. When I divide both sides by minus 1, I discover y is equal to minus 5. Which means after all of that, these two lines meet at here. Now I'm going to show you something interesting. By the way, they're all done like this. I'm going to show you something interesting. So it meets at this coordinate, minus 1, comma, minus 5. I'm going to punch in this line and the original line, which I think I have to do again. It's 6x minus y. 6x minus y is equal to minus 1 because I accidentally deleted it again. I'm going to put them both in the decimals, and we're going to see that they meet at that spot. So it's 8x minus 3y is equal to 7. And the other one was 6x minus y is equal to minus 1. Now let's see where they meet. Sure enough, minus 1 and minus 5. But I'm going to do something weird here. I'm going to turn off those lines. You see the first line up above? I'm going to copy it exactly. And then I'm going to copy the next line. There we go. Now, I want you to notice where these two lines meet. Oh, look at that. I'm going to turn off the blue line. I'm going to turn on the top line. Oops, I chose the wrong one. The second line. They're the same line. This is the simplified version of that. I'm going to do it with the other one. Turn this on. I'm going to turn on the other one. They're the same line. That's because this is the simplified version of that. Now, obviously, if we could just graph it, we'd see where they meet. And sometimes you're going to have to figure out lines based on graph. They're going to ask you to figure out the formula of that red line, and they're going to ask you to figure out the formula of that black line, and they might tell you where they meet. They essentially might go backwards on this. And that's a skill you'll have to do as well. So you'll have one point, which is good, and all you need is the slope of the other line. Now, to figure out the slope, you'd need another clean point. So we just search around. There's a nice clean point. So turning off the black line, I can easily figure out the slope of this red line because it happens to have minus 1, comma, minus 5, and its y-intercept is 0, comma, 1. Now I could see that on the graph. which means I could do delta y over delta x, and I would discover minus 6 over minus 1. I discover a slope of plus 6. And since I have the y-intercept, look at this, I could even write the line now, 6x plus 1. And look at that, I'm able to write the line. Now, notice you might say, well, I already have the formula up here. And yes, you're right, I can just rearrange this. This is another skill you should gain, is how do I rearrange the standard format? How do I rearrange the standard format into the line-intercept format, or slope-intercept? Well, you're going to have to learn how to get y is equal to on one side. Well, I'm going to put, let's do this one because this is easier. I could either put the y to the other side and make it positive, but let's just subtract 6x from both sides. Fair enough. The left side disappears. Now, when I have something multiplying by minus 1, when I divide everything by minus 1, essentially all their signs change. And that's not quite intercept, because you like to have, in the line slope intercept, you like to have the x value first and then the slope after. But look at that. I've successfully rearranged it, and that's exactly what we found down here. Right? I did this one by figuring out the slope, and I already knew the y-intercept, so I could just rearrange it. How did I do the slope? I did y2 minus y1, so 1 minus minus 5 is 6. 0 minus minus 1 is plus 1. 6 divided by 1 is 6, so the slope of this line is 6. And then I could see the y-intercept, which I could just put here, and I could just put the slope here, and I now have the line. You're going to have to do that, so once you figure out that line, you'd have to figure out the other line, right? So they'd give you the other line and ask you to figure out the value of that. Well, we happen to know that it goes through this point, which is helpful. And we can see that's not clear, that's not clear. We need to find a nice clean point somewhere. And you just kind of, that looks clean. Yep, there we go. So 3 minus minus 5 is 8. 2 minus minus 1 is 3. 8 over 3 is the slope of this. I don't have a nice clean, that's going to be minus 2 1/3, which is minus 7 over 3. So we're going to get a minus 7 over 3 b-intercept and a minus 8 over 5, or sorry, plus 8 over 5 slope. It's not going to be clean. So there's two ways I can do this. Let's see if that's true by rearranging this line up above. Let's subtract 8x from both sides. I'm left with minus 3, because these cancel, obviously. So I'm left with minus 3. It's equal to that, right? Let's rearrange it slightly so that it's in the proper order. Remember that when everything's adding or subtracting, you can rearrange them. So I get that. And let's make our life a little easier and divide everything by minus first. So essentially they all change. But if you don't like that idea, essentially I can just divide everything by minus 1 and change all their symbols. But if you don't like that idea, let's just divide everything by minus 3. Everything by minus 3. So I'm going to take this. We're trying to get that y is equal all alone. So we're going to divide everything by minus 3. And remember that really, when you have the right side like this, this is the actual division. And we'll get into that. And it's clear over here they cancel. But also be aware that you can just individually subtract it. And when you have something like this, you can rewrite it like this. Now, we don't like negatives at the bottom, ever. You never like a negative at the denominator. And it's clear that these are a negative divided by a negative, so they're going to become a positive. But there's no simplifying that slope. So all that happens is the minuses disappear, and we should put the x in front like that so that we can see the slope. But over here I have a positive 7 divided by minus 3, and we don't like negatives at the bottom, and this can't be simplified. So there we go. And that's the slope we have. And by the way, negative 7/3 is the intercept, which is the same as negative 2 and a third, which is the same as negative 2.33333333. So get good at that as well. I'm going to do the other ones, but you should pause and see if you can do them yourself. So the goal is always go step by step, right? So we're going to do this one first. It's plus 3 times a plus 3 times minus 1. Well, plus 3 times a is plus 3a, and plus 3 times minus 1 is minus 3. And then over here, you just think of it as separate, right, like that. It's going to be minus 3 times plus b, and minus 3 times minus 3. So if I want to write it down, it's minus 3 times plus b, minus 3 times minus 3. I can see here that I have a plus and a minus, so it's going to become minus 3b. And here I have a minus and a minus, so it's going to become plus 9. Notice that the symbols in the brackets, and you now get rid of the brackets, that's what we were doing. Notice the symbols in the brackets, this was a plus b, now it's a minus. This was a minus 3, now it's a plus. Changed because it was multiplied by a minus number. But I can essentially replace all of that with this. And you don't include the brackets anymore, because that's the point of multiplying out. Now I want to rearrange it. I can see I have a plus 3x, which is fine. And oh, sorry, it's plus 3a. Sorry, I get into the habit of using x, so we'll just replace that. And I can move the minus 3b here. I'll just put the a little bit closer. And I can even put the plus 9 next and subtract 3. And it's clear that, and don't forget to equal 0. And it's clear that 9 minus 3 is 6. So I get 3a minus 3b plus 6 is equal to 0. And I want it to the other side, so I'm going to subtract 6 from both sides. I get 3a minus 3b. What's 0 minus 6? Minus 6. It looks like I have an a and a b and a number. So it's done. Then you do the next one. This one I'm going to do a little bit faster. What's positive 3 times positive a? 3a. Remember, they're all things adding and subtracting in a bracket, so I'm going to have 4 things that add or subtract. What's 3 times positive 2? Plus 3 times positive 2 is plus 6. Then that's a minus 1 in front of the brackets over here, so essentially this bracket's just going to change their signs. I'm going to get minus b and plus 7. Is equal to 20. And now all I have to do is rearrange their numbers, their like terms. It's clear that plus 6 plus 7 is 13. Plus 13. And to get it to the other side, I'm going to subtract 13 from both sides. On the left, it disappears, and 20 minus 13 is 7. And it looks like we have a single line that looks like a line. We have an a, a b, and a number. Now all I have to do is see where they meet. Now notice the 3a and the up top and bottom match. Since they're the same sign, I'm just going to subtract it. And I encourage you to continue doing this, because this is definitely a weak point for most people. It's plus 3a at the top in the bracket, then minus, then open bracket, and it's plus 3a at the bottom. That minus that I've added is independent. So I got a minus and a plus here, so it becomes a minus. So what's plus 3a minus 3a, or just 3a minus 3a? 0. Then I open my brackets, I put the top term, I put a minus sign, I open my brackets, I put the bottom term, and I see that I have a minus times, or minus minus here, so it becomes a plus. Then I can just do it like this, and I can say, well, my minus 3b is a bigger negative number, so I know I'm going to be minus, and what's minus 3 plus 1, or 3 minus 1? Minus 2b. So that means when I subtract that line, that's what I get. What about the right side? You can use the same technique, even when it seems simple. Open bracket, put the top term, put a subtraction, because that's what you're doing, and then put the second term. I see that I have a plus and a minus here, so I replace it with a minus. Notice that both these numbers are negative, so we're going to go bigger negative, so we can just put a negative and add them together. So this is what we end up with. So I got to divide both sides, and you always want to check here to make sure you got your arithmetic right, especially when it comes out as weird numbers like this. So I'm going, it could be, so I'm going to make sure I got 3a, check, minus 3, and over here plus 9, so plus 6, so it's going to be minus 6 on this side, check, and this is going to be minus 3b, so this one's correct. And this one 3a, and it's going to be minus b, great, and then it's going to be plus 6, plus 7, so plus 13, subtract it, 7, plus 7. Then minus 6 minus 7 is minus 13. Minus 3 plus this minus 2. I got it right. So I divide both sides by minus 2, and I get b is equal to 13 over 2. And if you want to simplify, but your teacher usually likes fractions, that's the same as 6 and a half. And on Desmos, you'll see it as 6.5. Right? But your teacher will probably prefer it in fractions, like that. Now that I figured out b, I should figure out a. And to figure out a, I'm going to take the simplest formula, and wherever I see b, I'm going to put it in a bracket. So I get 3a minus bracket b equals 7, and I'm going to replace it with what I figured out up above. So let's just use 6.5. Now let's use 13 over 2, because this will illustrate a good point. We're going to use 13 over 2 in the brackets, and we're going to resolve the negatives first. Okay, we're just going to put aside our b, because that's our solution for that, unless I screwed it up. I can always put this whole thing into Desmos to see where they cross. Okay, so I just need to solve this, and you might say, well, let's first solve this minus. This minus times this thing just makes the whole thing in there minus. Get rid of the brackets. I obviously don't like working in fractions. What happens if I multiply each term by 2? Each term by 2. Well, it's clear that 2 times 3a is 6a. And it's clear on the right that 2 times 7 is 14. What happens when I take this number, which is minus 13, like this, and I multiply it by 2? Now you might be tempted to multiply the plus 2 times the minus 13 and then divide by 2, but just notice that when I multiply by 2, they cancel out, and I'm just left with minus 13. That's why I did it, to get rid of all fractions. And that's a good thing to always learn, because you want to make your life simple. So this is a little easier to do. I add 13 to both sides. It obviously disappears on the left side. I'm left with 6a is equal to 27. I divide both sides by 6. 27 over 6 is how I can't, yeah, they can both be divided by 3. And that's the same as 4.5. Now, it's pretty weird that they came into unusual numbers, but what I'm going to do, first of all, I'm going to change a to x and b to y. Then I'm going to pull up my Desmos, and I'm going to put it in exactly as written. That way I'll know if my expansion was right as well. So I got 3, a minus 1, exactly as I see it. And you know what? I'll just pull this over. Minus 3 times b minus 3 is equal to 0. And now notice Desmos can't do it, so I'm going to change this to y and this to x. And then I'm going to take the 3 and I'm going to make sure my a is x. And my minus y minus 7 instead of b is equal to 20. And now I'm going to see if that's where they cross there, 4.5 and 6.5. And sure enough, because I made my x a and I made my y b, it's going to cross at 4.5 comma 6.5. And that means I did, because I put it in exactly as written, that means I did my expansion correctly, because they do indeed cross at the point I found. And that's always nice to know that you did the expansion correctly. So just remember that Desmos can't take A's and B's. It considers them variables. Great, let's do the last one. You should pause, and always pause and try to do it yourself, because I cannot emphasize this more. Watching someone do it will not get you a good mark. Doing it will. Best athletes in the world get coaches, but they only get good at when they go out and practice. So I'm going to expand each of them quite quickly this time. This is a positive 5, so everything's going to stay the same size. And you'll see if you can follow along. I multiplied each term in the brackets by 5. Now notice that the minus 2 is going to change all the signs in the brackets. The n was positive, so it's going to become minus 2n. And minus 2 times minus 3 is plus 6. Now I just got to rearrange my like terms. So it was plus 25. So now notice that plus 25 plus 6 is 31. Then I've got to subtract 31 from both sides. And I get this. 62 minus 31 is 31. And this just disappears. Now it looks like I have one n, one k, one n, one number. Good. That's one line. Okay, let's look at the second line. 4 times k, 4k. 4 times minus 7, minus 28. Minus 1 times n, minus n. Minus 1 times plus 4, minus 4. Notice I just took the bracket and just changed all their signs. Let's add their like terms. So I'm going to move this minus 28 over here. Notice that the minus 4 and the minus 28 are both minuses. So I can just keep the minus and add those numbers together. Now to get rid of it, I have to add 32 to both sides. Something like this obviously disappears. Something like this is hard to see unless I rearrange it. Right? You can even do this. That's what minus 9 is. It's minus 2 minus 7. It's clear that the 32 and the 2 disappear. It's clear that 30 minus 7 is 23. So I have a second line. I have a k, an n, and a number. Now all I have to do is my elimination techniques. Okay, I can see the bottom one. If I multiply by 2, it'll match the top one. So I'm going to multiply everything in the bottom one by 2, and I get 8k minus 2n is equal to 46. So I'm going to keep my lines on the right, just because my teacher, you want to show your teacher you got there. And now all I have to do is add, and I notice the minus 2n, the minus 2n are the same sign, so I'm going to subtract everything. Use the same technique. Open brackets, put in the top term, put in a minus, open brackets, put in the bottom term. I can see I have a plus 8k at the bottom term, so it becomes minus 8k. 5k minus 8k is minus 3k. The terms above, the next terms, minus, open brackets, minus 2n, put the minus sign, put the bottom term in the bottom. The terms here should always cancel. If they don't, you did something wrong. So minus 2n plus 2n, canceled. And the last one, open brackets, 31. It's easy when they're both positive. It just becomes that. So I can see that the minus 46 is a bigger negative number. I could take 46 and subtract 31, and I know that I'll be negative 15. 46 minus 31 is 15, and I know I'm going to stay in negative. So I got this. I divide both sides by minus 3, and I get this. So that means I figured out k. I'm going to take the simplest line with the least numbers in front of k or n, and I'm going to, wherever I see k, I'm going to put it in brackets. I'm going to replace it with what I know k is equal to. 4 times 5 is 20. So I get 20 minus n is equal to 23, so I'm going to subtract 20 from both sides. And I get these will cancel. And this will become 3. Positive 3. And I'm going to divide both sides by -1. So these lines should cross it. If I make kx and ny, they should cross at 5, -3. So the easier thing to see if I got both the expansion and the cross correct is to put in exactly what I started with on the left. And for k, I'm going to put x. And for n, I'm going to put in y. And then I'm going to do the next line. For k, I'm going to put in x. And for n, I'm going to put in y. And I'm going to see where they cross. So they should cross, according to me, if I got it right, 5, -3. Doesn't look like I... Oh, I did get it right. 5, -3. So to really see it well, I would have to expand it. And that's where they cross. That means I did the expansion right, because obviously I got the right crossing point. And there you go. So expansion is an important tool, and you'll need it, and that's all there is to it.